Good morning, my name is Chelo Scritch, Head of Extrusion Department in Plus, and it's a pleasure for me to participate in this webinar with my colleagues Amparo Verdú. The objective of this webinar is to show you the extrusion process, the main processing parameters to take into account, including some products obtained in Plus facilities, and in the last steps to show the different extrusion technologies: blow film extrusion, cast sheet, pipe and profiles, blow molding, and multi-layer structures. In the first step, extrusion process, the extrusion is a process to obtain continuous plastic products with a constant cross section. The plastic material is molten due to temperature and friction action and pass through the die with the desired shape under controlled pressure and temperature. In this slide, it's possible to see one extrusion equipment. If we can remove the protective parts, it's easier for us to see the different functional parts. The equipment has a motor, a hopper to feed the plastic material in molten state, a metal cylinder called barrel with different heater elements, and at the end sensors, pressure sensor and thermocouples. Inside of the barrel we can find the screw. This is a conventional screw for extrusion technology. The screw has three parts: feeding part, where the plastic is in solid state, and the main function is to transport this material. The second step is the transition, where the material passes from the solid state to molten state, and the main function is to obtain an homogeneous product. And the last zone, the metering zone, is where the material is pumping to the die to obtain the final product. Each plastic material needs a different screw. It is necessary to select the best screw taking into account the characteristics of this material. To select the screw, we need to know the geometrical design, to know the channel depth, the pitch, the LS angle, and so on. The LD ratio is the relationship between length and diameter, and in the last step, the compression ratio. The compression ratio is the ratio between the feed zone channel depth and metering zone channel depth. In this case, for example, it is necessary to choose the suitable screw for each material. For example, for polyethylene and polyester, this is the suitable compression ratio. And in the case of polyamide, we need the last one. Okay, if we are selecting the screw, now it is necessary to introduce the extrusion parameters, the setting parameters. The setting parameters to begin to extrude are the temperature profile, is the suitable temperature in each heater element. It is necessary to know what is the main function in each part of the screw to define the suitable heater temperature in each element, and the screw speed to transport the material and pump it to achieve the suitable pressure and to obtain the final product. Besides, it is necessary to study some additional parameters to achieve a correct product, a good extrusion process. These are response parameters. These parameters are the melt temperature, is the temperature, this is the real plastic temperature with the material is feeding the die and to obtain the final product, and the pressure and torque. Both parameters must be constant to achieve a reproducibility product during all the extrusion process. In this point, I would like to show different products obtained in pilot plant facilities within different European, national and regional projects. For example, to obtain biodegradable sheets, to obtain trays in Bioform MAP. Other project is to develop new compostable material to manufacture bottles and pouches in BioBottle project. Some new bottles for care products, and to develop new materials from waste bakery products to obtain bags or package for these bakery products within the circular economy aims. In this project, the idea was to develop compostable nets to package vegetables and mussels products to avoid recycled problems with package with low weight and high volume. In this case, were developed a new compostable material to manufacture pipes in Hydrus project. To design new big containers to transport drinking water in a refresh project. In the last example, the idea was to use a recycled material to replace wood structural in aquacultural sector inside the dolphin project. And now my colleagues, Amparo Verdú, will continue with the presentation to show you different extrusion technologies.
According to the desired final product, we need to use different extrusion lines. As my colleague Chelo says, today we are going to review the main extrusion process. They are blow film extrusion, cast sheet extrusion, pipe and profile extrusion, and extrusion blow molding. Let's start with the first one. Blow film extrusion is a common polymer manufacturing process used in order to obtain products in different sectors. Sectors like packaging with grocery bags, garbage bags, and also different kind of pouches. In agriculture, we could find mulch film, silage, and also greenhouse films. And in industrial applications, we could find stretching films and also industrial bags. In this slide, we could see the general line that we use in order to perform this process. This line is formed by the extruder. As we have said before, the extruder is used in order to melt and mix the material, the plastic material, and pull up through the die. In this case, the die has an annular shape in order to obtain the tube called bubble. And also the cooling and the out-of unit. Okay. In this process, we use a special parameters in order to control the process. These parameters are the blow-up ratio. This is the relation between the diameter of the die and the diameter of the bubble. This relation gives us information about the transversal stretching that the film suffers during the processing. The stretching ratio is the next one. This is the relation between the takeoff speed and the extrusion speed, and give us information about the longitudinal stretching that the film suffers during the processing. The first line, this is the line placed where the diameter of the bubble becomes constant, and also the bubble height. So let's now see a video in order you could get a general idea of the process. The material gets into the extruder. This is the screw. And you could see now the die with the annular shape, the bubble. And these are the nib rolls in order to close the bubble. And now we have a flat film which is winded up in a roll. And after that, the roll, we could use this roll in order to make a final packaging operation. In this case, is in order to package bottles. Okay, so let's go now with the second extrusion process we are going to review today. This is cast sheet extrusion. Cast sheet extrusion it's a extrusion process that we could use it in order to obtain films or sheets for products of different sectors. In packaging sector, for example, for lidding, modified atmosphere packets, vacuum sealed packets, trays, blisters. In the building sector, building or construction sector, geomembranes, formworks, and shower trays. And in the automotive sector, door panels and car roofs. Okay, in this slide, we could see the general equipment that we need to use in order to perform this process. It comprises the extruder. In this case, the die is in order to obtain the flat form of the sheets, and the cooling unit that we call calendar. The calendar is formed by different rolls that are tempered and also chromed. In InPlus facilities, we could obtain sheets or films with a maximum width of 480 millimeters, and with a thickness between 40-50 microns up to 900 microns. It depends on the material. Okay, next process is the pipe and profile extrusion. With this process, we could obtain products in the construction or building sector. For example, protective wiring looms, rainwater pipes, window profiles, and garden fences. In the agriculture sector, also land drainage tubes and animal feeding, and also irrigation pipes. And for automotive sector, different kind of tubes, cable arms, and also door ceilings. And also for the medical applications, we could obtain blood and catheter tubes. This is a general overview of the line, the equipment that we need in order to perform this process. The extruder, as we have said in the other processes, is in order to melt and mix the material. The calibration unit, in order to keep and maintain the shape of the product, the final product. The cooling unit, and also at the end, the pulling and the cutting unit. In InPlus facilities, we could work with different materials, amorphous and semi-crystalline materials, and also with PVC. And we have different dies in order to obtain different shape of the final product. This is a video in order you could see the process, how it works. The material goes inside the extruder by the hopper. This is the cooling bath in order to cool the final product, and we could normally, if it's rigid or semi-rigid material, we could cut the profile or the pipe. Okay, and the last of the processes that we are going to review today is extrusion blow molding. In extrusion blow molding, we could obtain products that we could find it in different sectors, in packaging sectors, as bottles for food applications or daily products also. In industrial sector, different containers and jerrycans. And in automotive parts also, different tubes or fuel systems, and also for toys, different toys for children. Okay, in this slide we could see the equipment that we need. Also comprises the extruder. In this case, the die in order to obtain a tube called parison, and the blow unit. The blow unit, the blow molding unit, comprises the blow pin in order to put inside of the parison the air and the mold. Okay, in this slide is just to give you an overview of the process stages. When the parison has the length, the optimal length, mold closes over the parison and the blow pin goes inside of the parison. Gets put inside of the parison the air in order to expand the parison, and this parison could copy the shape of the mold, the desired shape. And after that, the mold opens and the finished trim is removed. Okay, let's see it in the video. This is the parison, the mold closes over the parison, and in another stage we could see the blow pin goes inside and put the air into the parison. Okay, remark that you could see now 3 different extruders in the top of the video. Okay, why? Why 3 extruders? This is because sometimes we need to obtain a final product with desired properties, but we couldn't reach these properties, all of these properties, with just one material. So we use, in this case, we use multi-layer structures. In order to obtain a multi-layer structure, we use a process called co-extrusion. Co-extrusion is a process that we use different materials in order to fit the same die, and we obtain a structure, a final structure that combines the properties of the different materials. In InPlus facilities, we have the different extrusion lines in order to perform co-extrusion. In case of blow film co-extrusion, we could obtain structures with from single layer up to 5 layers with 5 different materials. In the case of cassette extrusion, we could obtain also from single layer up to 5 layers, but in this case with 3 different materials, structures A, B, C, B, A, and for the case of the bottles with 3 different materials. So that's all for today. Thank you very much for your attention, and if you have any other question, don't hesitate to contact us. Thank you again.